Hello everybody, this is Mr. McNair, and this is going to be the first part of the Chapter 8 review. We're going to be covering questions 12, 15, 16, 18, and 19. Alright, number 12 says, given y equals negative 2x squared plus 4x plus 5, answer the following. Well, first they want you to answer this question based on what you know about the graph. So let's go ahead and graph this first. Alright, so the first thing that you want to do when you're trying to graph a quadratic is find your a, b, and c. So here a is negative 2, b is 4, c is 5. Remember, a is the number in front of x squared, b is the number in front of x, c is the constant. So you're going to find your vertex after that, okay? And the formula for your vertex is the opposite of b over 2a. Here, the opposite of b is negative 4 because b was positive 4 over 2 times a. A is negative 2. So let's simplify that. Negative 4 on top, negative 4 on bottom, that equals 1. Okay, so now we're going to make a table based around our vertex. Now the value of your vertex always goes into the middle of your table. So we're going to put 1 in the middle. And then I generally suggest that you pick integers to the right and left of your vertex. So bigger than 1 are 2 and 3. Smaller than 1 are 0 and negative 1. Okay? Now that you have those values, you're going to take those and you're going to plug those values into your equation. So our equation is y equals negative 2x squared plus 4x plus 5. And when you plug in negative 1, the value you should get out is negative 1. When you plug in 0, the value you get out is 5. When you plug in 1, you get out 7. 2 comes out to be 5. And 3 comes out to be negative 1. Alright, so from there, you can go ahead and plot those values. Negative 1 is here. 0, 5 is up here. Positive 1, 7 is here. 2, 5 is here. And 3, negative 1 is here. And then you're going to go ahead and connect your parabola with as smooth a curve as possible. Okay. Alright, so there's our parabola. Now, there's some questions that go along with this. So the question that we first want to ask or answer is, does this parabola open up or down? Well, this parabola opens down. And a parabola will always open down if the value of a is negative. We know a is negative 2, so therefore the parabola opens down. Anytime a is negative, parabola opens down. The axis of symmetry. Remember, the axis of symmetry is a vertical line that goes through your vertex. This here is the axis of symmetry, that line through the vertex. So since it's a vertical line, it will always be x equals. So that's why they have the x equals there. And it's going to be whatever the x coordinate of your vertex is. Here, our x coordinate of the vertex was 1. So that's x equals 1. All right. The y-intercept. The y-intercept is always going to be 0 for x and whatever value you have for c. And c in this problem was 5. So here, our y-intercept is 0, 5. The x-intercepts, we're going to go ahead and cross that out because our x-intercepts, as you see, they don't cross exactly at integers. So I'll leave that one alone for graphing. We could approximate those. Well, actually, we can find those exactly by using the quadratic formula, but we'll leave that alone for now. All right, and then our max or min. The maximum or the minimum is going to be based on the vertex. The vertex, remember, is going to be your highest or lowest point. So here is our highest point. So we have a max in this problem, and the max is at positive 7. All right, that's the y value of this vertex. All right, the domain. The domain is a collection of all of the x values, right? So this parabola, because it's going to continue to get wider and wider and wider, and I'm going to exaggerate it a little bit, is going to cover all of the x values, all of them. So the domain in this problem is all real numbers. Okay? And every quadratic equation will have a domain of all real numbers. Okay, because it will continue to get wider and wider and wider and span all of the x values. Now a range is a collection of all of the y values. Now we notice that our range, because it's the y values here, the y values. The range, the highest we get on our y values on this parabola is 7. So the range has to be from 7 down. So y, the range is y, has to be less than or equal to 7. Because once again, our parabola was up here at 7, and that was the highest, and it was everything else down. Okay? So there we go. That's problem number 12. Problem number 15. These say solve quadratics by factoring. So when you're factoring and a equals 1, and here a does equal 1 because you can't take out a GCF there, you find your a, b, and c. A is 1, b is negative 10, c is positive 16. When a is 1 in your factoring, you're looking for two numbers that multiply together to give you c, and at the same time add together to give you b. All right, so they multiply to give you that, and add together to give you that. So what multiplies to 16 and at the same time adds to negative 10? Well, that would be negative 8 times negative 2. Multiplies to positive 16, adds to negative 10. So we factored it, but we have not yet solved it. All right, what you're going to use from here is your zero product property. We know that these two things multiply together and give you 0. So that means that those values for x have to make those parentheses equal 0. So what makes this parentheses 0 here? Well, the value would be positive 8, so x equals 8. What makes this parentheses equal 0? Well, x would have to be there too. All right. Once again, 8 minus 8 is 0, so that works. And then 2 minus 2, that's 0. So those are your solutions. Okay, let's try one more, just to make sure. So here, once again, there's nothing you could take out as far as a GCF. So a is 1, b is 12, c is 20. Because a is 1, we're going to find what multiplies to give you c and adds to give you b. The numbers that do that are, what are those numbers? 10 and 2. X plus 10 times x plus 2. So we factored it. Okay, now once again we've now factored. Now we have to solve. What value for x here would make that parentheses equal to 0? That would be negative 10. What value for x here would make that parentheses equal to 0? That would be negative 2. And those are our answers. Now, just like we did in all previous problems, hopefully you remember that you can take these values and plug them in one at a time to make sure that they work and you get 0. That's especially helpful for multiple choice questions. Okay? All right. So, let's go to the next one. This one. Is there a GCF that factors out of all three terms here? Well, yeah. 5 comes out of all of those. So you want to take out that 5. So if we take out a 5, put our parentheses down, what's left in the first position is x squared minus 2x minus 3. Remember, when you're factoring something out, you're dividing it out. Negative 10 divided by 5 is negative 2. So that's how we're getting all of those values. All right, now that you have factored out a GCF, we know that a is 1, b is negative 2, and c is negative 3. Once again, because a is 1, we can find out what multiplies to c and adds to b. And the values that multiply to negative 3 and add to negative 2 are negative 3 and positive 1. And I'm just going to drop that 5 down. And once again, we're going to solve it using our zero product property. There's no way that we can make 5 0, so that doesn't play a part in this problem. However, we can make this parentheses 0. What value would make this parentheses 0 for x? Well, x could be 3. And what would make that parentheses 0? X would have to be negative 1. So these are our two answers, 3 and negative 1. All right, last one for this first part of the review. Here, is there a GCF that we can factor out of all three terms? No. Okay, so since there is not a GCF, the factoring methods that you could choose are either, well, first of all, let me say this. A is 2, B is 9, C is 10. So we notice that A is not equal to 1. Okay, so since A is not equal to 1, The two methods that you could choose from are either guess and check or factoring using the AC method. Because most of my students use the AC method, that's what I'm going to do here. AC method, you multiply A and C together first. 2 times 10 is 20, so I'll put that off to the side. And now you're trying to find two numbers that multiply together to give you 20, and at the same time add together to give you 9. Here, those two numbers we can find are 4 and 5. All right. So now we take the factors 4 and 5 and we break apart that 9x. So we're going to rewrite this 2x squared. Instead of 9x, we're going to put positive 4x plus positive 5x plus, we're going to bring down that c of 10 equals 0. We're going to, after you have these four terms, factor by grouping. The GCF that factors out of this first set of parentheses is a positive 2 and an x. So that leaves you on the inside with x plus 2. The GCF that factors out of this set of parentheses is a positive 5, so we're going to take that out. And that's, once again, will leave you with an x plus 2. Afterwards, we factor out the common binomial of x plus 2. Those are the same. If they're not the same, you've done something wrong. So we factor out that x plus 2. And what's left on the outside is this 2x plus 5. So we'll put that there, 2x plus 5. And once again, we're going to drop down that 0. Okay? So that equals 0. Now, once again, we're back to where we were in the previous problems. What value for x here would make that parentheses 0? Well, that would be negative 2. What value for x here would make that parentheses 0? Well, that one's a little bit harder to tell. If you can't tell just by looking at it, you could take that parentheses and set it equal to 0 to find out. So let's solve for x. Subtract 5 from both sides. We get 2x equals negative 5. And then we'll divide by 2 to get x by itself. So we get x equals negative 5 halves, or you might just want to put negative 2.5, whichever one. Okay, so our answers here are x equals negative 2 and x equals negative 2.5. Once again, you could take those values and plug them in for x here one at a time to make sure that that comes out to equal 0. All right, and there you go. That is our first part of the review. Hopefully it was helpful to you, and have a great day.